So I think we got to the point the other day where we were looking at, let's see. I'd say we got to for sure 31. Yeah, we just started talking about 32. So I'm going to bring up the spot that we left on the PowerPoint. And we'll move ahead. Anybody remember what those are called? What's this one called? What's that one called? Romex connectors. But yes, the trade name is a little less than desirable. The reason why I tell you guys that is because that's exactly it. When your journeyman this summer tells you, hey, run to the truck and get these, that way you know. Okay? Or the same thing with the motor termination junction box. That's also known as the pecker head. Yeah, I didn't make it name, but I was funny if I didn't make it name. But that is what it is. And that way you guys are at least privy to the information that you need to have. And that's ultimately what this class is all about. It's getting you guys prepared to go out and work this summer and be able to communicate with the people that you're going to be working with about the parts that you're going to be installing. So we're going to start up on page 32. We did talk a little bit about this. Let me see if I can do some toy box. Talking about these. And why did we say these were necessary? Yeah, that's pretty much it. Is if your box is recessed too far back into the wall, you may not actually have enough area to be able to close down, and you're actually going to have exposed conductors sitting right next to that drywall. So yeah, we want to make sure that that's squared up. So I just wanted to let you guys know right now, since there is a couple of people that are gone, I am recording the discussion that we're having today. It's just going to get posted up on YouTube, so we can review it. The reason I'm doing this is because there's going to be some explanation at the end of class about what your assignment is. And for me to only have to explain it once is beneficial to both me and you to be able to review. So we're going to kind of, I'll forward this link out when everybody's done with today. That way we can actually, you can have a record of it. Because this next assignment, it's not going to be a hard assignment, but it's going to be a little bit confusing on what the requirements for the assignment are. So we're going to talk about that at the end. And then that way you guys can reference back to this. The big thing that we want on this is to have you guys have the ability to come back here and reference what we talked about in class. And the difficult problem that we have is if I were to just have you guys tune in or have a class outside of just have everybody tune into the, like say the YouTube channel, is that we can't have the discussion. So the reason why I do it this way is so hopefully we'll have to see what the sound quality is. My computer last year with the sound quality wasn't great, but I'm hoping that this one's going to give us an opportunity that we're actually going to be able to capture that discussion that we have in class. So the people that are outside of class, and when you guys go to review, that's where a lot of the learning happens, is from us talking about your guys' experience and me being able to tie that in. Go ahead, Jackson. Yeah, what is it? Yes. Just search my name. I think it's in there. Brian P. Mitchell, 7'6". Brian P. Mitchell. Yeah, let me look here. I don't know how to find myself on here. I think it's just my Gmail, Brian P. Mitchell 76 at Gmail, maybe. I don't know. Anyway, that's not the point. Let's get focused back up on what we need to accomplish today. So we're going to bump ahead real quick on the PowerPoint here. So the thing that we're going to talk about next, specifically on the PowerPoint, is we want to talk about some ceiling boxes. And we got a little bit, we're moving a little bit further away from where we are in the book for just a second, but I promise we will circle back to finish this up. We only have a few more pages left, and there's some stuff, some content on here that I want to make sure that we talk about. So we talked a lot the other day about just the regular receptacles. Receptacle or device. Those are typically the ones that we're going to see that are going to be square or rectangular. When we're talking ceiling boxes, we're actually going to be talking about the round boxes that we're going to be mounting lights on. And there's several different varieties of those up there. And I wanted just to have a short minute of time to talk about what the actual intentions of mounting these particular boxes are. I'm going to send these around for you guys. But the three big questions on this slide is no gang signs here. Obviously, when we're talking about a round box, we're not talking about how many gang the round box is because they're round. Can't put more gang with a round box. It's just designed to mount a light up. So that's the big thing here. The differences here, obviously, this one on the lower left is going to be just the bar hanger. And this one is specifically going to be used when you're putting this up in a house and you're trying to get a light in the center of a room, but you don't have a stud that's in the center of the room. So you take this up and you mount it between the two rafters, and then you're able to center that light between the two rafters. Let me see that one quick, Dylan. Not necessarily this one. This one probably wouldn't be what I would recommend in a home for a homeowner to change out. And actually, this would probably be the best thing to do if you were going to, if you were going to leave it. This would be, say for instance, a great spot for this would be in like a closet, where you're not going to have a super huge light ever in a closet. There's actually some code references that give you a little bit of the specific idea of the light that you can put in there. Yeah, this isn't for hanging heavy loads. Yeah. Yep. So exactly that. So we'll say we have a 10 by 10 room here, and our rafters aren't going exactly in the center, which would be 5 foot, and we wouldn't be able to nail this right onto one of the rafters to be able to get it center of the room. So we would nail this between the two rafters, and then we would be able to take and move this to the center of the room, and then tighten the screws inside to make sure that that stays there. That's the big thing. Go ahead. Rafters are the things. They are the things that are holding your roof up. Oh yeah. Yeah. So like we don't have a good example in here, but so out in the lab, the 2x4s that are going on top of the structure, those are simulated rafters. Yep. It beams. Yep. Beams. Yep. Yep. All right, and so that's the bar hanger, and then we have this. What do you suppose the name for that is? There's no gang. No gang signs. We're back out of the hood, brother. Ceiling box. What kind of ceiling box? Nail on, a round nail on. Round nail on. Yep. And then this one is a very specific type, and we can learn some stuff by this just by looking at the screws and looking about how the box is constructed. So we see these big screws in here, and we see the ability for a piece of wood to run through here. This would be the black one in the middle of this slide. We can see that, hey, look, that looks kind of almost heavy duty. That's a little bit heavy duty. Yeah, it's a lot heavy duty. This box is designed to be mounted directly on one of those rafters that we were talking about. And these two big screws run right up into the center of the rafter, and then you can hang a pretty good load off of there. There'll be some ratings that you get in the. There will most likely be some stamped in there, but then if it comes in a box, usually these particular ones come in a box. You'll actually be able to see what the ratings that you can hang, the weight rating you can hang off there. Go ahead, Eddie. Yeah. Yep. Or a real heavy ceiling fan. Yep. You can do that. Yeah. And then this is another pretty good example of that. It's just in a different application. So the one on the lower right side, down on the bottom there, you see that that's a nail on, but we got some pretty significant hardware going along with that. So I would say that the rating for this one right here is going to be a little bit less, considering that we're expecting that to hang off the side by these 4 nails than we would see off of this. Just because of how, you know, that physically is gonna, that one side's gonna be wanting to tip away, whereas this one we're anchoring that right in the center. But yeah, those are both like heavy duty rated boxes. Yep. And that's primarily stuff you'll see once you get out into, if you ever, this summer, if you're doing custom homes, something like that. Most apartments don't really get into that. Maybe if there's a ceiling fan in the living room of the apartment, they might see something like that. But honestly, most of the lighting boxes that you guys are going to install are going to be just a round nail in the bar hangers, especially in bedrooms. Custom homes, you know, that's a different story. You're going to see a lot of this stuff because there's an opportunity for expansion there, and the homeowner may want to go ahead. Go ahead, Tobias. So the middle one, this one, it could be. I'm gonna probably say that it's most likely the same depth as that. That's the way I've seen them in the past. Is that these guys right here are pretty much the same thing with there. We just have a little bit more support structure there. Yeah, this one is in fact quite a bit shallower right here, because this part right here in the center that's intended to be drilled up into the stud. That's only going to be about a ½ inch. And what you got to do here, or 5/8, depending on the sheetrock that you're going to put on there. What you have to do there is when you're going to make that light up, you actually have to stick the wires up in the sides of those holes. That adds a little bit of a degree of difficulty when you're making it up. But the actual installation of the light is really slick. Yeah, you're just able to kind of, how many wires would we expect to have to connect to the light at this box? Not 4. Not 2, not 1, 3, because we'll have to have a hot, tell the switch to come off, or tell the light to come on. We'll have to have a neutral to return, and then that other silly one, the ground. Yeah, these are almost, you can't put a switch in here unless you get some special kind of mounting hardware, and I'm not familiar with it. Yeah, these are primarily lighting boxes. So when you see a round one, brain automatically says, "Oh, no switch here. This is probably going to be a light of some variety." Okay. Say that again. Yeah. It'd have to be a very specific situation where you would see that, and I can't think of one. Yeah, possibly. Yeah. Yep. Okay. Now we talked a little bit about this the other day. The 4-square box, if you need to mount a device horizontally. Here's the 4-square. What kind of box are we talking here? No, this is a 4-square, but what do we have going on here? See, I wouldn't put a single gang when I'm talking about 4-square, buddy. Come on, keep up with me. Yeah, that might not be a bad idea. Okay, and then what do we got going on here? Everybody remember what that is? Mud ring, exactly. Yep, and we're going to actually install this right on these screws. So this is going to take, we're just slide that right on there, screw those screws in, and then we got a cool box. And then to answer that next question, do you think there's going to be more area inside this box with a single gang mud ring on it than just a regular single gang box? Heck yeah. So the mud ring is going to be used, since the front of this box is flat, right? And how these are mounted is that you're mounting right up flush with the stud, right? So if you were to mount it flush with the stud, like say for instance out in the wiring lab right now, if we just nail this to where the front of the stud is equal with the front of here, when somebody comes in to finish the room to put the sheetrock on, there's going to be a 5/8 or a ½ inch gap between where the front of our box is and where the front of the sheetrock is. And it's basically an extender, yeah. But the real reason why that is because we actually install the devices inside of here. We want the devices to be tight up against the box. We want the screw to be actually tight. And a lot of times it doesn't work out that way. And when we start to look at devices, we'll kind of understand that there's the little ears that are on the switches and the outlets. So they're kind of designed to help keep a tight fit to the wall, and then the actual box. But a lot of times, depending on the sheetrock crew that you have, you could be in a world of hurt depending on that. And then you have to get into those box extensions, and then there is even a possibility that you'll actually have to take and shim out the back side of your screws for your devices, just because you have so much space to make out. We'll talk about that when we get into devices a little bit more, and it'll become pretty obvious when we get out into the lab and start doing that work. Yeah. Okay, and then I got a little bit more explanation about a box extender out here. This is a great example. So right here we can see that this is a metallic box. What we have right there, Romex connector. We see that that's sunk back into the wall quite a bit, and we don't want this when this GFCI gets installed. It's going to have a half-inch worth of opportunity to take over and work out the tile. And a lot of times when we see tile like this, especially when we see a GFCI, where are we going to be? In a wet location. It has an opportunity to get flat. And if this is sitting over here on this tile, this receptacle is sitting over here on this tile and it gets wet, we just made a conductor. So this is going to prevent that receptacle from actually making conductor to conductor contact with the metal in that box. So, and then there's a couple of examples of a 2-gang and a single gang. Okay. Rarely, they're not used often. There's like anything on what we're talking about, there is a definite specific place and a definite specific time. This is exactly that. This is exactly where you want to use that. If that space is too straight from where that outlet needs to mount into this spot right here, and where the actual surface of the wall is, yeah, that's exactly what you need. All the time to keep it safe on that deal. But would you use this on everyone? No. Most of the time we try to get these, and these are built. I'm just going to give you this example of the single gang here. These are built with the anticipation of having a finished wall. So when we put a single gang box on, this is pretty much what we're going to see in all houses. For every outlet and most switches that are in the roof, you're going to see a box like this behind it in residential. So these little nubs are designed specifically to mount up flush with the edge of the stud. You stick that right on there, probably holds it, and then this is automatically the right depth for the finished wall. Yeah, and then all the sheetrock that you have to do is they have to touch them off your heel up, and actually they get it, they get the fuel over there, and take it, fuel that spot on the wall, they put it over there, and sometimes cooking wood. Boo. Yeah. Too many questions. Say that? Okay. All right. So now we're kind of swinging back into the box or into the book here. We're getting caught back up in the book. So we're talking about FS or weatherproof boxes. FS or weatherproof boxes. So we're on page 33 now. Let's see. We have a couple of examples up here on the board. Let's specifically talk about the differences between this one and this one. What can you tell me about this one that is different than this one? Gangs. Yeah, when we're talking about these, we actually do have gangs now. Again. We're talking about the gang. This is a single gang, and specifically, this one has a opportunity for us to put 2 pipes in the bottom. That's a lot of pipe availability for a single gang box. Yeah, go ahead. Good question. I really don't know. So possibly it could be possibly for just like if you needed to put the box in, but you didn't want to put a device on it, you just wanted to put a cover on it. You could possibly have a cover that's designed that way, but really like a blank cover where it's just basically like what we see up in the ceiling, but meant for being outside applied to that box. That's possible. You can see that. Obviously, the way that we really want to see this is we want to see a device mounted in here, and then we want to see the cover mounted on the device, making a good seal. These are specifically for being is the big difference here, is that we have an opportunity when we're talking about weatherproof boxes. We see there's many different varieties, but when we're talking about like device boxes, you can have 1 to 2 gangs. Yep, a couple of gangs there. All right, so FS boxes are weatherproof device boxes that, with the appropriate cover and seal, can be mounted in wet locations. FD boxes are deep weatherproof device boxes. Wow, talk a little bit. FS boxes are available with hubs for the attachment of rigid PVC. So that's what we're talking about right on the bottom of the slide there, is the actual PVC is going to come stick right into those little holes, and we're going to glue it in there, and everybody's going to be happy. Yep. All right. So junction or pole boxes. We're going to talk about those real quick. Non-metallic junction boxes are available in various sizes and depths. Non-metallic junction boxes can be mounted outdoors in wet locations with the appropriate ratings. Non-metallic junction boxes are used to splice conductors and mount components and as a pull point. So looking at the picture on 34 there in your book, that's basically all it is. It's for us if we get a long somewhere, like for instance, a really long car wash. That's a great one. And we need to tie the laser sensor from the front side when the car enters the car wash to the laser sensor from the back side when the car leaves the car wash. We need to tie those two together. We can take and we can run that conductor inside of a PVC to the great electrical conduit that we have, plastic electrical conduit. And then at the middle, if it's a 100-foot long spot, that's a long pole. We may want to add a pole box in there or a junction box just for us to be able to not have to pull that wire so far, or maybe we need to make make some electrical connections inside that box. Yeah, go ahead, Eddie. Yeah, yep. So when I'm talking like a pull box, it's exactly that. Instead of having to go the entire length of, or here's another great example. So part of what we'll learn about when we're talking about raceways is that there's only a certain amount of degrees of bend you can put in a conduit run before you have to add a pull box or a junction box, and that number is 360 degrees. So you can only put basically 490s between a junction box. Otherwise, it just becomes too hard to pull the wire through, and you can start to the resistance of that pull. If you're pulling it hard enough, you can actually damage the wire. So there's some regulations that we'll talk about when we move into raceways. But yeah, that's basically what it's all driving down to, is that we see that those polar junction boxes in there for exactly that. If we have a long pole, we can throw one of them in, or if we need to make something else. Go ahead, Jeff. So typically what we would do on something like this is we would actually create our own hole. We'd take a drill and we would drill the hole size that we need, and then we would make sure that we get the appropriate connector for the raceway that we add in there. But that way we can kind of make them however we want. And you'll see a lot of times like metal boxes, metallic boxes, we sometimes weatherproof metallic boxes, we do the same thing. We make our own holes in there, and then we get the appropriate connectors to make sure that that still stays sealed after we penetrate that. So, yeah. Okay. Any more questions on that? Okay, next we're going to talk about floor boxes. Now, you probably don't, maybe, you've most likely seen a floor box. You probably don't have any experience. Yep, there's a lot of them out there. Yep, there's some upstairs. That's honestly where you see a lot of floor boxes. Like if we were to have another level above us, we could look up here and probably see a bunch of them. And it would actually, that hole right there, that would actually look just like that hole where there would be, that's an old roof penetration. There must have been some sort of equipment or a pipe that went up there, and we can tell by the screws that were coming down right there. But yeah, that's exactly it. We would see conduit running over to the bottom side right here, and we would see that conduit pop right in. This one would look like in concrete. Like you actually, we would set this in a concrete, like before they pour the concrete, we would set it down on the ground and then run our conduit to it. They would pour the concrete up to the top of our box here, and then we would have a nice sweet pour out there. Yeah, pretty simple. That one also kind of looks like it's probably designed for concrete. The ones that we see that we can add in, like if there was another floor here, we could just go cut a hole in the floor with a core drill, and those kind of after the floor where you're just kind of sticking it up through there, you can do those with metal boxes. But these are more specifically designed to be put right in concrete, because guess what? Concrete is a corrosive environment, and we can't put metal conduit inside of concrete because it's corrosive. So, yeah. All right. So floor outlet boxes provide an enclosure for receptacles in concrete floors. Floor outlet boxes and covers must be appropriately listed for use in floors. Floor outlet boxes are available in various depths, sizes, shapes, or round or rectangular. Floor boxes are available with dividers to separate line voltage conductors from communication conductors. And that's important to remember too. And I will note, as we're going through this, it wouldn't hurt for you guys to be familiar with Article 314 in the NEC. That's where we're going to get a lot of this information, and I can promise you that we're going to be nailing this pretty hard next semester. So that separation that I was talking about between the 120 volt regular communication power, that's pretty important. You don't really want those two paths across, even in close proximity. Especially when we get a lot of computer loads. There's some computers that are doing their work, and also see data line. You could actually see some interference on your data line that could actually maybe slow down the transmission of the data that you're hoping to see. So yeah, lots of stuff going on there. Any questions about those? They're pretty simple. Not a lot to really unpack there. They're kind of fun because you do all of that. You do all of that work before they pour the concrete. And then they pour the concrete, and you get to go back and see, well, did they knock my box over and it's just sitting kind of cockeyed in the concrete now? That's always fun. It's like Christmas. Oh, let's go check and see if the concrete guys moved our boxes from where they should have been. Well, there's very little you can do. There's very little you can do. Now, a lot of, Mike, you could probably attest to this. When you see a concrete box and you're doing a pour, you're pretty dang careful with it. Yeah, because that electricians put a lot of work to make sure those are where they need to be, and they kind of, so most of the time there's rebar around that you're trying to tie that stuff to make sure that it doesn't move. But say for instance that we get the height wrong, like the box at the top of the plastic box is actually sticking out higher than the floor is, then we kind of got a problem, right? Now what do we do? Well, a lot of these are designed. This one. Yeah. Yeah. You're talking about like if you're pouring around an electrical room or someplace like that. Sure. Yep. He's talking about actually not actually seeing the floor box, but seeing the plastic going through the floor, the plastic pipe going through the floor that could be actually transferring that wiring up through multiple floors. Yeah, and that's a pretty common thing that we do too. So, yeah. Okay, moving on. Communications for low voltage boxes and rings. Okay. Why don't we need to back to the box there? Anybody venture a guess? Who said it? I think I heard Eddie say it. Yep, it's low voltage. Exactly. There's no hazard there, right? Well, there's minimal hazard. Minimal hazard. So let's see. Yeah, that's really what it's driving for. Is that all we're really needing on this particular setup is we need a spot to mount our data receptor. Right? We really, the data line is just an Ethernet. It's going to come in and terminate on the back of that faceplate and someplace through that faceplate too. Real simple stuff. Let's see, 2-gang box with divider allows line voltage on one side of the box and the low voltage on the other. A low voltage ring provides an outline to cut the sheetrock around and provides holes to screw a plate into. That's really as simple as it is. Yeah, this is, you can put these in here. Typically, in residential, you will see an outlet data panel. And I'll do exactly that. I'll put the data here and outlet here, or vice versa. And then they can put that divider. This one right here is if somebody messed up. You can use these in the commercial. The cut is because it's just go ahead. Yeah, it's like an Ethernet line or a cable TV. That's typically what you see in residential. You don't have an Ethernet line actually make the cable that has those two in it. Yep. And this one right here, the one with the divider in it, it would be instead of so right here we could probably we were able to feel this up on the right, we see it's done. Or some sort of a mounting between the hand bracket and here. This might be stuff, this might be stuff that's depending on the name. But say for instance, there's stuff here. With these voltage dividers, you can actually have these two it would be together in a box like this. We would have those together, and actually this one's designed to have see that little fur line there? Oh yeah. Sweet baby Jesus. All right. Okay. And then that other one right there, that's for if you need to add an outlet or decided to move your computer somewhere. There's your line in and get it to there. That's pretty much it there. Okay, so surface mount box. Now you guys may have seen some of this stuff around. This is the trade name for this is called wire mold. Okay, now this would be, for instance, if we needed to add a electrical circuit into a room that we didn't want it to have. We wanted it to be exposed, but we wanted it to look decent. It would be better to run wire mold than it would be just to run silver conduit down the wall. This is basically that. It's the opportunity for you to add an electrical circuit somewhere and have it look better than pipe on the wall, where you can't actually fish it through the wall. You have to come and mount it on the surface. A lot of times, I know I did a lot of this work in wire mold work in the Ramcoda for fire alarms. We had to do a ton of this work just to get fire alarms put in all the rooms. So we had no choice. We didn't have the ability to get into the ceiling. So we had to run all of this. It's this wire mold. It's basically just exposed raceway across into the ceiling, or mounted it to the ceiling. And that's what this thing is here, the surface mount box. And this particular stuff is the non-metallic stuff. And we'll learn a little bit more about this. We'll talk about it because there's metal and non-metallic styles of this raceway. And then these boxes are obviously where that raceway terminates. So surface mount non-metallic boxes are used to add outlets to finished rooms. They're often used in conjunction with surface non-metallic raceways. Surface mounted non-metallic boxes are typically used for low voltage or communication outlets. Surface mounted non-metallic boxes are available with adhesive back or maybe fastened with screws. If screwed in place, surface mount non-metallic boxes may be listed to use up to 600 volts. So you can, I mean, it's not great. Not great to use this plastic stuff if you needed to add an outlet somewhere, but if you screw it in place, right here says that you can do it, okay? So I don't recommend it. There's other things. This is kind of like a last ditch effort to please a customer that they really need an outlet somewhere. You can probably do this, but man, if you have to run an outlet, I just would recommend that you use the metal stuff. Yeah, the metal stuff is where it's at. All right, so next, the old siding box. These aren't real fun. These are not a good thing to have to deal with. Siding boxes, they are exactly what they are. Okay, when you're putting siding on your home there, it says we got to have an outlet by the front and by the back, and then we got to have one for the air conditioning guy. Those are requirements of the code. So this is what we have to put on that beautiful looking house that you just built to allow that to happen. Basically allowing us to transfer our wiring from the interior of the house to the exterior and have it look reasonable. Have it look reasonable. So siding boxes come in many styles. The siding blocks pictured above are listed for use as junction boxes for conductors. These types of boxes have holes that fixture and devices screw into. Siding blocks may not be rated to be used as junction boxes and require a box to be installed behind or inside them. Siding blocks may have two pieces, the luminaire type pictured above, a back plane that is mounted to the sheathing of the house and provides an edge to slide around, and a front plate that acts as a decorative cover. Siding blocks are available with built-in in-use covers. Now, we didn't really talk, that's the example of built-in in-use cover. Built-in, there it is. Built-in, that's what I'm talking about. So this is where I'm putting in your brain right now. I'm locking it in there. In-use cover. All covers that you see on your section is an in-use cover. There may be a reason why I'm telling you to remember that. In-use cover. Okay? So this guy down here is a built-in in-use cover. It's actually part of the material itself. And then obviously that final, I believe it's the final page. Nope. Yeah, I believe so. I believe it is. Yep, I believe it is. Yep. 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 So a lot of times we'll do when we're doing the exterior of the house, we'll just take pointing out, pointing into the house, when the exterior guys on the exterior of the house, they see this, they'll cut it out for us, and then we'll oh crap, all this stuff out of the wire. Typically this would be like bigger, you can tell it's more likely like in the ground but yeah, that one right there, the receptacle siding block with in-use cover, that actually kind of looks to me like it's designed to fit on top of this. And then that other one, the receptacle sliding box, that actually looks like they're intending that to be a junction box that you install on the exterior. So, yeah. And then 39 there, the in-use cover. In-use covers are required on receptacles and wet locations, so on the exterior of your home. Now, there is a few opportunities for us to not have to put in-use covers on. We'll talk a little bit about more of those when we hit code real hard. The difference between those two is that one, there's three different locations. One's a dry location, one's a damp location, and one's a wet location. There's some discrepancies and there's some rules in the code that say and define what a damp location is as to what a wet location is. And there's different sort of covers that you can put on if you're in a damp location, like the little flip covers, the little snap covers, the gray metal ones that you see on some outlets, older stuff, or if homeowners do it, they would rather have just snap outlet covers, but they're not listed to be able to be used in a wet location. Okay, in-use covers are designed to keep water from entering the device when the cord is plugged in. You can tell by looking at that page 39 and also looking down here. These are designed to be able to have that outlet cord come through the bottom side of it. That's how we're able to maintain the water status with the cord being plugged in. It's actually almost around the cord. That cover is 100% closed, but the fact that it's not for the bottom of the cord. And you'll see that. You'll see that. You'll see it when you see it. Yeah, go ahead, Ed. Basically, there is no difference. One of them, it's just in how they're constructed. So this one, the built-in is just exactly that. It comes as a unit. You just install it, and it's already there. The in-use cover would be the other built-in. We have this box out there on a receptacle We would still have this part, but it would be a cover that you would have to add after, not necessarily along with that side. Yeah. They're essentially doing the same thing. It's just in a matter of the application of how you're wanting to use that situation. Yeah. Okay, and then the final thing that we need to talk about, and man, we like talking about this in non-metallic boxes. On page 40 there, is that a box? Yeah, a box to me has some sides and, you know, looks like a box. This looks like a plate. But let's just read about it. A meter socket siding block provides a mounting surface for meter socket. Okay, siding fits into the channel around the blocks. The meter socket siding block allows siding to expand and contract without being pinched by the mounting screw of the meter socket. Meter socket blocks are available in various sizes. So the thing that I would say that I probably see this used most likely on is for when you actually will see them like your cable TV or your telephone or your internet folks. They mount their boxes on stuff like this. I've never installed one of these. Typically, the meter just gets mounted right on the wall. Yeah. And like I said, that's the only time that I've ever even really seen these used is for when data service gets hit on that. So, okay. All right. Well, that pretty much brings us to a close on that particular chapter. So we need to talk a little bit about the assignment. So those of you who have your computers and those of you who have your phones can navigate to the MyWDT This Class homepage. I will also do that on the screen up here for you guys to be able to recognize what's happening. Log in. And then we're going to go to 135. I'm going to view as a student. Change view. So this is what you're going to see. And then you're going to, when you get to this point, you're going to roll on down and you're going to see IEL 135 Unit 2 homework.docx. And you're going to open it. It's right here, Dylan. Look at my screen. Did everybody get to that spot? IEL 135 Unit 2 homework. What? That's bull, ain't it? It's unacceptable behavior. It's an example of what not to do, sir. Open it. Oh, here it is. It is open. It's open. It's open. It's open. Okay. When you're opening that document, you will see this. You will see this. So, real quick, what we're talking about here, I'm going to read this, and I want you to be 100% sure you understand what the requirements are for this assignment. So, we'll read the instructions here. I'm wanting you to take a picture of 5 separate device boxes, add them to a Word document, and explain how they came and what the devices are doing in each. So, each picture that you take. Yes, you do. Yeah, you have to take a picture yourself. Each picture is going to explain to me what's happening. Now, I can look at this and I can tell some things. This is ultimately what I want you guys to be able to do, and that's the sign of this exercise, is that I can look at this and I can tell you that I have 3 single pole switches and 1 3-4 forward. How can I do that? Exactly. Exactly. Okay, look here. You see off, we see off, and we see off. Now,
The only switches that have an on and off on them are single pole switches, because you can only be in either the on state or the off state. No, the single pole are only is only one. So one switch controlling the line. Yeah, the one without. Yes, the one without it could be exactly that. The 3-way or 4-way, depending on the situation of the circuit. So that's one little example of what I'm talking about there. The other thing that's unsimple, we'll get the color of that here. Okay, so moving on with the instructions. I also want one picture of the ceiling box and one wall-mounted light box. Also uploaded to your document. I want to know how each light is being controlled, either a 3-way or single pole switch shutter. Points will be awarded on the requirements being met, as well as the efforts put into the document. Effort. That's what we're going to see in the video pointed out. You can tell if you took a picture and it was only a second. Tell them you're not going to get off on a point. Please review the attached example of what is expected. So this is what is going to be expected. You will have a picture. You will have an explanation of the picture. Here is the 4-gang switch box that controls the lighting in my kitchen and dining, or dining room and kitchen. First switch controls the garbage disposal. The second switch from the left controls the chandelier above the kitchen table. It's a 3-way switch that can be turned on and off by the back door as well. The third switch is on the next page. Controls the can lights in the kitchen. The fourth switch controls the undercut lights. The last two are single pole. I just made that up too. It's not actually my kitchen. You want it the outside of. Yeah, that's all I need. So let's talk about. Yeah. I don't care. Yeah. How is it misspelled? F-O-R-T-H? How come it's not red? How come it's not red? Oh, yeah. Yeah. Okay. All right. This is unacceptable behavior. None. There needs to be a U there, right? Did it really? I was going to say, wow. Wow. Okay, so let's talk about this now. Let's go back to that explanation. Take a picture of 5 separate boxes. So we're talking about 5 different boxes from your book. 5 different metallic boxes. So some of them can be a single pole, like, oh, a simple outlet. That's one box. But where are non-metallic boxes found? Are they found in commercial buildings? No. Specifically, they're found in residence. So where are you going to have to do this? At your home or apartment or something similar. Something similar. So yes. Yep. 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 Interior. Interior, of course. Yep. Yeah. All the apartments I've done have been in non-metallic, and I've done a lot of them. So go ahead, Mike. Oh, okay. All right. So let's think about the 5 different ones. Okay. And also this last one here is going to be difficult. This last one, the one that we're talking about, the one wall-mounted lighting. Where's it at? Porch light. Wall-mounted lighting module in your bathroom. Exactly. So, and I want to know about what's going on with these things. I want you to explain to me. And here's why. Yeah, I can tell you all day long. Oh, look, here's the ceiling box. Here's what it does. I can tell you all day long. What I'm wanting you to start doing is I'm wanting you to be looking around in your environment and learning these things. Like, hey, look, I know exactly what kind of box is behind this wall. It's a 4 squares, shallow, metallic box mounted on, most likely words escaped me. It's not a stud, it's a
The word escapes me. Anyway, I can see it in my head. I just can't remember the word. But I can do that. I can see that, and that's what I want you guys to do too. It's going to bother me if I don't come up with that. It's probably even in here. Bracket. That's what it is. It's on a bracket, a mounting bracket. Yeah, mounting bracket, and I can probably even show you it in the book. Yes. Say that again. Nope, that's a ceiling box, wall mounted. That really should give it away. I'm listening. Yep. There will be a very, very clear divide between those who put effort into this and those who don't. Okay, that's the big one for me. It's a big one for me. The reason why I'm so specifically highlighting effort is because this is an assignment that I created for you guys to not just have test scores. Okay, otherwise this class is entirely test scores. Some of us aren't great test takers. I get it. That's why I'm expecting you to take this opportunity to learn what we're talking about in the book so you're prepared when we take the test. Tobias. Fourth is spell wrong? No. We should make sure that our electrical inspector isn't here when we look at those. Yeah, you're the authority having jurisdiction. Okay, any questions? This is available right on your homepage too, Jackson, you know. Okay. All right, is there any questions? I hope everybody is 100% clear because I'm going to be kind of a stickler on this. Two separate pictures of the same box? Yeah, that's two separate pictures. Yep. Yes. Non-metallic box. Any kind of non-metallic box. The instructions are right there. A ceiling box and a wall-mounted light box. Yes. This will be due next week, and we will also be having our test on non-metallic boxes on the second half of class next week. Yeah, there's a ceiling box. Yeah, ceiling box. So let's look at ceiling boxes in your chapter. Yes, Tobias. Yes. Is there inherent danger? Inherent danger. So what you're saying is you ran Romex out of your wall and wired it directly into your range. I would think that it's likely okay. Likely okay. It would be a humongous code violation. A humongous one. Like they'd probably make you leave your residence. Yeah, until you get it fixed. Yeah, well, I think, you know, Wyoming is worse because it's actually the fire marshal that's the inspector. It doesn't really matter. No, because who are you going to call when the thing starts on fire? The fire department. The rest of this part you have that you would be normally spending class, guess what you should be doing? Your work. Taking pictures of outlets and switches. Get there. Huh? These aren't non-metallic boxes. Non-metallic boxes. These are metal boxes. Yep, non-metallic boxes. Huh? You can go home and do all of your work. Bobby, I feel for you. I don't want to go outside either. I got to go down and do a career fair. Okay, thank you, everybody.